This three graph will be given. Let's say this question comes up. I will give you the words, but the graph you are expected to know how to draw. Most likely I will ask you to draw also. So don't waste those marks. Learn how to draw it properly. So in exam, the graph won't be given. You need to know based on the question itself which property goes to which state, and then you need to know how to draw the graph. Okay. So let's look at A. So A is the one where we have T3 equal to 350 degrees Celsius. So from here, the state 3 you can take from the previous example directly. But let's ignore that first. So we start from state 1. So state 1 is very straightforward. 10 kilopascal saturated liquid. So always remember this, we always put state 1 as a saturated liquid. Unless I tell you otherwise. If nothing is mentioned about state 1, it is always saturated liquid, 10 kilopascal. I mean, not 10 kilopascal, 10 kilopascal is given by the question. Saturated liquid is always the case. So once you know that it is saturated liquid, then all you need to do is to find the enthalpy and also the specific volume. Once you got a specific volume, then you can move on to state 2 by calculating the work pump in using V delta P. So by using this, you can get the work pump in equation, and from here you add with H1, you get H2. So that is the H2 value. State 3, this is just from the table. The same value also you can get from example 1. So I hope none of you get this wrong at least for this part, because this is just very straightforward, just slightly different value. Okay, so then we are done with up to state 3. So state 4 actually is exactly the same method. So now we know that, So now we know that state 4 has been changed to 10 kilopascal, but we also know that S4 is equal to S3. So from here, you can find the quantity, and then based on this quantity, you can also calculate the enthalpy. So if your mathematics is a little bit better, you probably can just straight away skip the quantity part. Like you can just compare both sides and then get the enthalpy. But that one a bit long, so I mean not a bit long, but a bit more complicated. So I don't want to teach that. But some students do that for my exam, so that's fine. If not, just do this step by step. Okay, because S is a common denominator, so we can actually just compare left and right. One side is enthalpy, one side is entropy. You get the answers. Okay, so from here, then now we have H1, H2, H3, H4. You can calculate Q in and Q out, and subsequently the thermal efficiency. So if we compare this to example 1, like I mentioned, this whole thing is the same as example 1, just that the boiler we are moving down the pressure. So from 75 kilopascal to 10 kilopascal. So a comparison here will show that the thermal efficiency has increased from 26 to 33.4 based on example 1, but quality of the steam decreases. So for this question, the quality is 81.3% around that, but from example 1 it was 88.6. So this fits well with what we mentioned in when we were talking about this method of increasing the efficiency, lowering the pressure. Okay, so that's part A. So now we can move on to part B. So moving on to part B, you don't actually need to redo the entire first stage, because state 1 and state 2 remain the same. Nothing has changed. Right? So state 1 and state 2 remain the same. You can just carry over the H1 and H2. Now, so this here I got a little bit lazy. You can just take the answer from me, because the method is exactly the same. So H3 now, from 350 degrees Celsius, it becomes 600. So if you get from the table, this should be the H3. And repeat the exact same method, you should get the new quality and then new thermal efficiency. So again, we discussed this, so you can compare these two slides. So from the previous slide, thermal efficiency is 33.4. Now that we have increased the temperature of the boiler, or rather the superheated temperature, you can see that thermal efficiency increased from 33 to 37. And quality of the steam has also been improved. So from 81.3 to 91.5%. So again, method exactly the same as the previous slide. So this is for your own practice. These are the final answers. Just compare and see whether you can get the same thing or not. Okay, so I think you can guess that C also same thing. So in C, the thing that we change is 3 megapascal. We change the pressure from 3 megapascal to 15 megapascal. So here, H1 remain the same. That's all. So only H1 remain the same. So you need to recalculate H2. Then you need to recalculate H3 and H4. So from here, again, quantity has changed, efficiency has changed. So for this comparison, once again, because we are maintaining the other state, we are only changing the pressure from the previous question. So you can see that now thermal efficiency has been further increased to 43%. And quality of steam then decreases from 91.4 to 80.4%. So now in moisture content increased by 11.1%. So like I said, these three examples from my side, I'm only just trying to let you practice, and also it is just to show you in terms of the numbers how all the three methods that we mentioned will improve the cycle, and also how it affects the cycle, because there are also issues where the quality of the steam reduces. Okay, so these are the three things here. So very straightforward here. So tomorrow we will go into all the what we call the modified cycle, basically. How we change this ideal cycle so that they become better. There are two ways for that you study. Alright. So any questions? We still have 3 minutes. No? Then okay, then that's all. We will try to change your timetable for tomorrow. Just watch out for the timetable. Alright, that's all.